Hello, this is Mr. Newman. This is Compound Inequality Notes 2 on unions. So we're going to pick up where we left off yesterday. So yesterday this is sort of review, compound inequality, two inequality statements connected by an and or an or statement. Yesterday we did the first type, which is the intersection, a compound inequality connected by the word and. These are the and statements. Its solution set contains only numbers satisfied by both inequalities or belonging to both solution sets. So today is a little bit different. Today we're looking at what is called a union. So oftentimes the way that I remember union is I think of two people coming together in a union, a marriage. They would sort of both bring things with it into that sort of relationship. So classic example. I know that you guys don't have CDs anymore, but a long time ago when I got married, my wife and I both had our own CD set, and so when we came into marriage together, into our union, so to speak, our CD collections kind of got mixed, and so we actually had some albums where we had duplicates because we both had the same CD, but we also had a lot of music that was just sort of our own music. So I had a lot of, jazz music that my wife definitely did not have, but that also became hers within the union. And there was a lot of music that she had that I would not have cared for. So our CD collection was sort of a union in a way, in that it was both sets sort of was a solution of our current CD collection. So a compound inequality connected by the word or its solution contains all numbers that are in either of the two sets. Sometimes it's in both sets, sometimes it's only in one of the sets. It does not matter. A solution can be in either one of the sets or both of the sets. It does not matter. So it combines the two sets. So as we look at this, right, if we were graphing for a union with the word or, graphing the compound inequality x is greater than 7 or x is less than negative 2 will look like this. Because of the or, you could have values that start at 7. Well, actually, they don't include 7, non-inclusive, 7, but that are greater than 7. So anything that's greater than 7 would meet this requirement. And you could say, well, what about 8? Well, 8 is greater than 7. Or is 8 less than negative 2? Well, yes, it's greater than 7. It's not less than negative 2, but it doesn't matter. The or lets you do one or the other. Then we would also have solutions that are less than negative 2. So for instance, negative 4 would be a solution to this inequality because, well, negative 4 is not greater than 7. Because it's an or, it is less than negative 2. And so therefore, negative 4 would be part of the solution. And so you get sort of two areas that are shaded. In other words, your solution is in sort of two parts. This explanation down here in your notes basically says exactly what we're just talking about, that there are two areas in another line, and therefore it's a union to combining these two areas. You could be in either one of the areas and be a solution. We used the symbol U. Remember yesterday when we used the upside down U, that meant intersection. This is a quick reminder. And so union, easy way to remember that is just if you already had a set of numbers of some sort. So for example, here are some examples that you might try down here. If I had negative 3 is less than x is less than 5, is that going to be an and or an or? So I kind of look at those and I say, well, if this is a compound inequality, is this going to be an or statement or is it going to be an and statement? In other words, could I have a value that's greater than negative 3 but not less than 5? No, the way this is written that x has to be both greater than negative 3 and less than 5, so this is going to be an and statement. So when I graph this, because it's an and statement, I will be shading in between those 2 points, just where they overlap. Okay? If it were an or statement, take a look at number 4 now, where I can be less than 2, or I can be greater than 8. I get a slightly different pattern. I think you should be able to pick up on what's going to happen here. And then I shade in one direction, and I shade in the other direction. And so you see sort of this middle part is now the opening, and I have the solutions going right and left. Okay. You also have to be careful. There are going to be some where there are going to be or statements, like for instance on number 6, where you're getting x can be greater than or equal to negative 5, or x can be less than negative 3. Well, as it turns out, when we graph these, greater than or equal to negative 5, I'm going to graph this way, but less than negative 3 graphs this way. Now remember, because it's an or statement, this is not an intersection. This is a union. And so you could be in the section where you meet both of the requirements, like negative 4, for instance, is greater than negative 5, but it's also less than negative 3. Or you could be in one of the sections that only completes one of them. For instance, you could have like 10, which is greater than negative 5, but not less than negative 3. Or you could have a value of negative 6, which is less than negative 3, but not greater than negative 5. And so in this case, we find out that, well, this actually turns out to be all real numbers. And the reason for that is that there's no single number that's not either greater than or equal to negative 5 or less than negative 3. So I'm not going to continue with the notes. I will continue answering them after I stop recording, and I will upload my answer key as completed notes into the notes folder into the shared area.